Hello, Professor. Today I'm presenting NeuroLearn, an interactive educational platform designed to teach the complex world of brain-computer interface, signal processing. The core challenge in neurotechnology is the gap between abstract academic theory and practical application. Brain signals are essentially invisible and consist of raw numbers, like the voltage readings shown here. They don't intuitively map to human interaction. So, NeuroLearn solves this by providing a step-by-step visualization of the entire processing pipeline using real EEG data. Our target audience ranges from university students to researchers and educators looking for a classroom demonstration tool. Looking at the main system use case diagram, we see the primary user flow. Once a user logs in, the system includes browse modules as a core action, which can be extended by selecting a learning path and using various educational resources. I've broken the system down into specific functional areas. The first one is the learning module use case. This shows how a student interacts with the curriculum. They move from an introduction to reading explanations, which is linked to interactive visualization. Second, the signal processing pipeline is a diagram vital as it shows the technical sequence. The user loads a dataset, either a sample or a custom one, and then moves through pre-processing stages like applying filters and removing artifacts before the signal is classified. The activity diagrams helps us model the behavior of the system. The complex learning module activity shows a parallel process where the system displays the intro, explanation, and visualization at once. Notice the decision note at the end. A student must score at least 70% on the quiz to mark the module complete. The signal processing activity maps out the mathematical logic. It starts with a raw signal explanation, moves to a bandpass and notch filtering, and ends by creating a feature vector that the classifier uses to calculate probabilities. The class diagram defines our software architecture. The signal processor class is the engine of the app, using the EEG dataset and processing stage classes to handle data. It also interacts with the classifier class to predict the final intention. The state diagrams help us track the status of the system objects. The module state tracks if a module is locked, in progress, or completed. And the signal data state is particularly interesting as it tracks the data as it changes from raw to filtered, artifact-free, and finally classified. To understand the timing, the sequence diagrams show how the objects communicate. For example, in the pipeline sequence, the student sends a next stage command to the controller, which then triggers the signal processor to apply a bandpass filter. The backend is powered by a relational SQL database. We have tables for users, learning modules, and user progress. We also store EEG datasets and metadata like sampling rate and channel count, and achievements table to gamify the experience. Finally, we bring it all together in the UI mockup. Here we have the dashboard when you can see the progress so far that the student or educator made while presenting the whole process. After that, we have the Learning Modules tab. Here, we go on a step-by-step learning to the whole dataset. Firstly, as you can see here and explained in the state flow diagrams, we go from raw data with bandpass filter, active or removal features, and at the end we classified a probability for an event to happen after analyzing the whole dataset. Here, we're explaining the step-by-step process in a more human readable way, so the student or who is interacting with this app understands how the flow of data transformation works. As I've already told you, we have a specific tab named Parameter Lab, where we can adjust all the parameters of our processing so we can modify the final response. Lastly, we have a quiz where the student can test their knowledge so far. And to gamify the whole experience, I've added a special achievements tab where they can be rewarded by going through each step and each module and course at a time. Thank you for watching this video, and thank you for offering me this chance to expand my knowledge and to make my progress into developing the final thesis application more easier. Have a good night.